this is the part 1 of the video review key. So I'm splitting this up into 2 sections. We're going to do questions 1 through 4. Questions 5 through 9 will be in a second video because they're probably going to be pretty long. There's multiple parts to a lot of these problems. So let's start off with problem number 1. So what I'm going to do is problem 1 and problem 2 are the same, so I'm just going to do one version of each of them. The second one is just for you to get some extra practice. Okay, so we're just going to do number 1. You'll be able to do number 2 on your own. It'll be on the handwritten key. But I'm not going to do it in the video. Okay, so problem number 1 is asking us to do a lot of things, so we're just going to kind of take it one bullet at a time. First thing says identify the vertex, the x-intercepts, and the y-intercept. So let's go through that process. Okay, the first one says identify the vertex, so let's start with that. Okay, so I'm going to identify the vertex. Well, the vertex for every ax squared plus bx plus c, which this is the standard form, is going to be negative b over 2a, okay, to get the x, and then plug x in to get the y. So I'm going to get a point. I'm going to find the first part of the point by doing negative b over 2a. So let's start with that. So in this case, the x part of the point is 24 over 2. Well, my a is negative 3. So I'm going to say that's 24 divided by negative 6. That's a negative 4. All right, now I need to plug that back in to get y. So I'm going to say my y is equal to negative 3 times negative 4 squared minus 24 times negative 4 plus 60. Okay, so let's go to our calculator and do that. Okay, so I'll bring my calculator up. So let's clear out everything on the screen already. Okay, and I'm going to plug in. So this says negative 3 times negative 4 squared. Okay, be careful that you're typing this in just like you see me typing it. If you type it in differently, you might get an error message or it might miscalculate. Okay, so all of the parentheses that I'm seeing as I'm plugging in, I'm making sure that those show up when I'm inputting into the calculator. So it looks like when I plug in a negative 4 into f of x, my output value is 108. Okay, so my y is 108. So my vertex, the answer to this first part, identify the vertex, is the point negative 4 comma 108. Okay, there's one. Problem 2, part 2, is saying find the x-intercepts. Okay, well, every x-intercept, C-E-P-T, intercept. Okay, every x-intercept is some x value, but we know that the y value is 0, so we're going to use that to our advantage. I'm going to go back up to this equation. I'm going to say I want to leave x. I want to solve for that. This is going to become 0. So I'm going to say 0 equals negative 3 times x squared, okay, minus 24x. Okay, so let's try that again. Okay, this is my x comma 0. So it's negative 3x squared minus 24x. I'm having some problems writing this problem. Let's do it again. Okay, minus 24x. There we go. Plus 60. Okay, and so I have to solve this problem. This is just a regular old solve the quadratic equation, and you have options. If you wanted to, you could try to factor this. It is factorable, but they're pretty big numbers. Okay, you could use the quadratic formula here. It would give you the right answers, but I'm looking at this and I'm saying, hold on a second, I can make this problem look way easier than it does now because every single one of these expressions has a GCF of 3 in it. So I'm going to actually divide everything by negative 3. When I divide the first part by negative 3, I get x squared. When I divide 24 by negative 3, I get 8. And when I divide 60 by negative 3, I get negative 20. This is way easier to work with than what we originally started with, so I'm going to stick with this one. And the reason I did this is because this is very easily factorable. If I can say what multiplies to negative 20 and adds up to 8, well, that's x plus 10 and x minus 2. Right? And so I'm going to get my 2x values out of this pretty easily. I'm going to say in this case I get a negative 10 and I get a 2. Okay? So that's good. That did it without using the quadratic formula. If you didn't notice that and you wanted to use the quadratic formula, go right ahead. You can just plug into the quadratic formula and you're going to get the same 2x values that I got. Okay, so let's write down my 2x intercepts. That is negative 10, 0, and positive 2, 0. So that's 3 points. Last one it says is find the y-intercept. Well, y-intercept is the opposite of x, so I'm actually going to use this little tiny space here. We don't need a lot of space at all to find the y-intercept. A y-intercept is 0 comma some y value. So I know that x is 0, so I'm just going to go to my equation and say the y is going to be negative 3 times 0 squared minus 24 times 0 plus 60. Okay, so this was a little trick that I gave you. I said it always ends up just being that C value because the first two cancel out. This is 0 squared 0 times -3. That's all 0 minus 0 plus 60. Well, 0 minus 0 plus 60 is still 60. Okay, so my y-intercept is 0, 60. Right? So I did the first bullet, and it asked me to find the vertex, the x-intercepts, the y-intercept. That's done. Right? I can put a little check mark next to that, and we are finished. Okay. Part B is asking me to find the domain, right? The second bullet saying find the domain and find the range. That's really not all that easy without a graph. We could do it, but let's wait on that, right? Finding the symmetrical point to the y-intercept, same thing. Not all that easy unless we have a graph, so let's wait on that because the last one's actually saying, well, graph it, right? So why don't we start with graphing, get these points that I do have on the graph, and then we'll come back to those other ones and see if we can find the answers, okay? So if I'm looking at this first point, the vertex, it's got a big value, 108. My graph only goes up to 10, so I can't just count by ones. You're going to have to scale your graph in this case in order to get the right answer. In fact, I can't even count by tens, right? If I counted by tens, I'm at 100, which means I'm going to count by 20s. I'm going to say, you know what? This is 0, 20, 40, 60, 80. This is 100. 20, 40, 60, 80, this is 200. Okay, so I'm not even labeling everything. Just as long as you can show somebody that you're counting every 5 dashes is worth 100, let them figure out on their own that means that we're counting by 20s. Okay, so now I can say let's go over to -4. Okay, and I can go up to 100, and 120 would be the next full jump. So I know that I'm kind of somewhere pretty close to 100. Right, because this is 120 and that's 100. So that's where I'd put -4, 108. Okay. My x-intercepts are at -10, 0, which is still -10, 0. I didn't scale my x at all, my x-axis at all, so it's still going to be counting by ones, right? And I'm going to go over to 2, 0. Okay, so I'm going to label these. It says graph and label each point you found. We call them the critical values. So I'm going to say this is the point, -4, 108. Okay, I have the point 2, 0, and I have the point -10, 0. Right, those are the 3 points I found. Okay. I can find the I can put the y-intercept on pretty easily because I counted by 20. So I'm going to say 0, 0, 0, 20, 0, 40, here's 0, 60. It's this point right here. So this is the point 0, 60. There's my y-intercept, right? And so the reason I did this is because now it's pretty easy to actually go through and find my symmetrical point, right? Because there's my axis of symmetry, and I'm going to count 1, 2, 3, 4 points gets me to the axis. So I'm going to go 1, 2, 3, 4 points. I'm going to have another point right here at -8, 60. Okay? So I have identified the symmetrical point just by using the graph, right? So let's draw this graph. I have 5 points on here. That means I can draw a graph. So I'm going to say, let's see if I can draw a nice one. It's tough to do with this pen. We'll do the best we can, right? There is my parabola, right? So now it's actually not all that bad to identify the domain and the range. So if I want to answer this, it's -8, 60. Okay, I just used the graph to find that. The domain for all quadratic functions, every parabola is getting wide forever, so it's all real numbers. My range is going to go as high as 108 and then come back down. So I'm going to say the y value is less than or equal to 108. Okay, so that is all of the bullet points here: vertex, x-intercepts, y-intercept. We identified the domain and the range. We found that symmetrical point using the graph, and we showed them a picture of the graph, and we included labels when we did that. Okay, so here's your second problem. I'll let you do this all on your own. The answer's on the handwritten key that is posted above this video, so you can use that as a reference. And if you still have questions after that, feel free to ask them. Okay, so let's go look at problem number 3. They're asking us to find all solutions to an equation, and I put in parentheses for you. By all, I mean the real number solutions and imaginary number solutions. And they said, after you're done, leave your answer in simplest radical form. So this is basically just saying, solve the equation. So I'm going to take all this stuff on the right, and I'm going to subtract it over. So it's -2x squared. Well, that goes with 5x squared. Minus 7x goes with -3x. And when I add 10, I just got to add that onto the end over here because I have nothing to connect it to. Okay, so this is 3x squared minus 10x plus 10 equals, all of the stuff on the right will cancel, so I'm going to use a 0. Okay, so now I'm looking at this and I'm going to try to do what I did last time. If I can find a GCF, I might be able to divide it away. Unfortunately, there is not one for 3 and 10, so I'm not going to be able to do that. So I'm going to go to the quadratic formula, and I'm going to say this is 10 plus or minus square root of b squared minus 4ac will be negative 10 squared 100 minus 4 times 3 times 10. That says 100 minus 120, which is negative 20. So my b squared minus 4ac, negative 20, all over, okay, this is all x equals 2 times 3, which is 6. Okay, so I've used the quadratic formula. I found my b squared minus 4ac. Okay, this is going to be an I solution. So let's go over to the side again. We need to simplify this radical. So I'm going to say the square root of negative 20. Okay, well, let's break that up. 4 times 5 gives me 20, and I like the 4 because I can square root that one. Okay, and the negative 1, we have a definition for the square root of negative 1. That's what we called I. So here's what we have. 2, which comes from this. I, which comes from the square root of negative 1. Square root of 5. I didn't do anything with that. That's the one that we have to leave alone. So I'm going to rewrite my expression now. It's going to look like 10 plus or minus 2I root 5 all over 6. So I just replaced the square root of negative 20 with the simplified version. I have one more step to do. We're almost done. I'm looking at 10/6 and 2/6, and they look like they can be simplified. They all have 2's in them, so I'm going to say 5 plus or minus I root 5 all over 6. So it looks like this one had two imaginary solution answers, two complex answers, okay, and we are in simplest radical form, so we are good to go. So again, problem number 4, or 3b in this case, is very similar. It's also probably going to be solved with the quadratic formula, and you're going to try to solve that and see if you come up with real or imaginary solutions. Okay, so we have one more problem to do in part 1, and that is simplifying a complex number that has a lot of operations in it. So when you see fractions, which I have 2 of them in this problem, I need to go to these problems and I need to rationalize the denominator. So here's what that means. To rationalize a denominator, you can't have I in the bottom of the fraction. So we need to go to both of these problems and separately get I out of them. So let's just start with the first one. So I'm going to say 4 plus I over 2 minus 3i. I'm kind of doing this off to the side, and then we'll bring the final answer back to our original problem. Whenever you have a binomial in the denominator, you're going to have to multiply the top and the bottom by the complex conjugate, which is the same thing but with a plus sign. The top and the bottom get multiplied by that complex conjugate. So the bottom, when I FOIL all this out, is going to look like 4. And I'll let you do this is minus 6i and plus 6i, which cancel. And then I'm going to end up with a minus 9i squared. So I'll let you go through and FOIL all this out and see that you have a negative 6i and a positive 6i that cancel. On the top, I'm going to have to do the same thing. I'll show you the full FOIL on the top. It's going to look like 8, okay, plus 12i, okay, plus 2i, plus 3i squared. Okay. So I have some cleaning up to do because I squared we know is negative 1. So I'm going to fix this up a little bit. So the top, the first thing I see is that this 3i squared is really 3 times negative 1, okay, which is negative 3. So this really says 8 minus 3. Well, 8 minus 3 is 5. Okay, 12i and 2i is 14i. Okay, so that's now my top of my fraction. And again, same thing here. This says negative 9 times negative 1. Well, that's 9. So this really just says 4 plus 9, and that's 13. Okay, so now I have a rationalized first fraction. So here's what this looks like. 5 plus 14i all over 13. I simplified this expression into this new one. I need to go do the exact same thing again with the second one. So this second one's a little bit easier. So let's just go right here, and I'm going to say 6 minus 5i over 4i. Okay. To rationalize this one, because it's a monomial, it's just 4i. It's not like the first one where there was a minus sign in there, right, a subtraction problem. I'm just going to say in this one, it's easier. I can just multiply the top and the bottom by I. Right? So you have two situations. One with a binomial, that's where the complex conjugate comes in. The second one only has a monomial, one term. So I can just use a regular old I. So the top of this one, when I give the I to both of the parts on the top, it's going to look like 6i minus 5i squared. The bottom is going to look like 4i squared. Right? So I get that situation again, just like we did up here where I had I squareds that turn into negative 1. So this is really going to be negative 5 times negative 1, and that's 5. Okay? The bottom is going to be the same thing. It's going to be negative 4. And then this is positive 6i, right? So I made a little switch because all of my complex numbers should look like real number first, imaginary number second. So because I squared away the I here, it turned into the positive, right? Or it turned into the real number. So this is the a plus bi way of writing the same thing. Okay, so I made a little switch. So let's go back to my original problem. I just took 6 minus 5i over 4i, and I turned it into 5 plus 6i over negative 4. Okay, so I'm going to make one little change to this second problem before we get started. I'd like to do common denominators. Okay, actually, you know what? I'm not even going to make the change. We don't have to. We'll do it as we go. All right, so here's what we're going to do. We're going to turn these into a common denominator. If I want to add together two fractions, these are both fractions, I need a common denominator. My common denominator for 13 and negative 4, I'm just going to tell you is 52, which is just 13 times 4. That's the smallest common multiple that 13 and 4 share. And I'll let you, again, off to the side if you want to work it out. If you don't believe me, 13 and 4 multiply to 52. Okay, so I'm going to have to figure out how do I change 13, which is what my old denominator was, into 52. Well, I'm going to have to multiply the bottom by 4. Okay, and that means that I'm also going to have to multiply the top by 4. Okay, I can't change the bottom of a fraction without also changing the top. So 4 times 13, there's the 52. But that means I need to multiply the top part by 4 as well. So it's going to be 20 plus, and again, if you want to go to your calculator, 4 times 14 is 54i. Okay, so I changed the first one. I got to do the same thing with the second one. So I'm going to do, okay, this says I need to change this into a positive 52 so it matches the one over here, which means I need to multiply it by negative 13. So that negative sign is actually really important because I not only need to change 4 into 52, I need to change negative into positive. So I'm actually going to include that negative sign. Okay, so I need to multiply the top by the same thing. So negative 13 times 5, well, that would be negative 65. Okay, and negative 13 times 6 would be minus 78. Okay, I. Okay, so there's my common denominator versions of what I started with. Okay, we're almost done. The only thing I need to do now is put this into a big fraction. Okay, so I'm going to say 52, and I can combine the real number parts. 20 plus negative 65 is negative 45. Okay, so that's just the real number plus the real number. The imaginary number is 54i plus negative 78i, and that's going to be minus, looks like 16i. Okay, so this is the sum of the original two problems. The only thing that we have to be careful about is they asked us to leave our answer in a plus bi form. Okay, so we have one more step to do. A plus bi, I need to fill it in so it looks like this. A, so some number, plus b times I. So I actually need to make it look like this. This doesn't look like that. This is one big fraction. This is made up of two parts. So here's how I'm going to fix this. I'm going to separately give the 45 and the 16 their own denominator, right? So watch. So it's kind of like what we had up here, right? Both of these had a 52. I'm going to kind of split it back up. I'm going to say, okay, 52. Okay, that's got the 45. Negative 45 over 52. That's my A value. Okay, minus, because 16 is negative. Okay, 16 over 52. Okay, that's my B value, I. Okay, because the 16 had the I, so I'm going to attach the I onto that. This is my final answer. Okay, so when you are adding and subtracting, we always want our answers to look like the things that we started with. Right? We started off with adding together some complex numbers, so I want my final answer to also look like a complex number, a plus bi. So once again, your second problem is a similar problem. It's actually a little bit easier because you only need to rationalize one problem, right? But you should be able to complete that on your own, and the key will be posted for you.